Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we'll be covering association analysis. That's often known as market basket analysis. In fact, it's about analyzing relationships, quite often between product purchasers, very often in retail scenarios. So for example, you're familiar maybe on websites that you visit where you're proposed frequently bought together. You're looking at an item and the system, the website proposes that frequently customers buy another product with this one. Or maybe you want to look at more over the customer's life cycle, that customers that bought this also bought that. However, they didn't necessarily buy it at the same time on the same day. So association analysis and recommendations can be very, very useful in retail, in particular for cross-selling, effectively for providing recommendations to customers. But also it can be used in the other way around, in terms of if you have a set of established rules and there are people that are not following those rules, then maybe there are examples of fraud. So you could also look at breaking the rules and use that for fraud detection. So very often known as basket analysis, let's get now into some of the details behind association analysis. The first thing to do is to just look at some data we've got so you understand what we're doing as source. So here we have a fact table with some customer sales transactions. And if we just preview it, we can see that we've got a number of columns. The ones that are interesting to us are the order ID. Effectively, this is a transaction ID. And we have a product ID for the item, the product that was sold in that transaction. And we also have the customer ID. And it's actually by using a combination of two of these, for example, the order ID and the product ID, that's how you know which products were bought in the same transaction. Or you might want to use the customer ID and the product ID so you can identify which products a customer has bought over their lifetime in the store, or whatever this data refers to. So this is the core information, and there can be very, very large volumes of this that we want to mine to actually produce recommendations about if customers bought this product, they also bought that product. So how do we approach that? Well, within the predictive analysis library, we have a set of capabilities that cover association analysis, and the main algorithm we're going to use is called Apriori. So as always, go to the documentation and find the algorithm you're looking for. So association, we have Apriori, and there are two versions. We'll see both versions. You can find out more details about exactly how you work with this kind of algorithm. And in particular, you need to know about how you generate the procedure you're going to use. And you do that in _sys_AFL. You also need to know what are the input that you're going to put to the function, so the input table and the parameters that you can specify as well, and also what the output will be. And with Apriori, the output is generally a set of rules which can be output both to a table, but also can be output in PMML format, which is actually predictive markup language, which allows you to then send models to other solutions or process them with other solutions if you want to do that. So it's an independent predictive model interchange format. So if you've not already seen the videos at the start of the series, the getting started and the key concepts, please do that, because we're not going to have time in this video to cover some of the basics about how you work with the PAL. The thing we should look at though is calling the Apriori, and we can see that we call the wrapper generator as always, and the main thing we call is the Apriori rule. That's how we're going to focus on this with the input and the output tables. So let's now look at some of the code. I've got some example code already. Now, as always, we first need to create the procedure in the _sys_FAL schema, and then we'll work in our application schema to create the tables and views and do the analysis. Now, if you're not familiar with what you're seeing here in terms of the schema sys_AFL, please review the key concepts video earlier in this series, which explains how all of this works. So we need to create 4 types because we saw that there are 2 input tables and 2 output tables. So the data and params are the inputs, and the rules and PMML the outputs. And what we can see I've chosen this time to use order ID and product ID as our input data. So we're going to be looking basically at items that were bought together in the same order or the same transaction. And parameters table is the same pretty much for all predictive algorithms. The rules you'll find information on in the documentation of the structure, and the same for the PMML output. The signature table we need to create incorporates these 4 table types into a table, and then we call the wrapper generator. We're going to create our own procedure called pal_AP, and it's going to be based on the Apriori rule, and the input we're putting is in that signature table. So let's now run that first example and create the procedure. The procedure is now created. The next thing is to look at our application setup. So here we're going to work in the PAL schema. First thing is that we need the order ID and product ID. We need those 2 columns, in fact, in that order for this Apriori algorithm. However, we don't need to pull all of those potentially millions of transactions into a separate table. We can simply create a view with the right columns we need in the right order. So that's what we've done here. We can create the parameter, rules, and PMML tables actually simply by just using the table types that we created as models. That way we don't have to write the same code twice. And we've inserted here some standard parameters. We'll see more details of these parameters later on. So let's now run this code. And we can see that's running and it's all happened correctly. And then what we finally need to do is actually make the call. So this is the very first time we've done it. So in fact, we can just simply go and call the pal_AP procedure that we've created, giving it that input view and what we set up for parameters, rules, and PMML output. So if you now run that, we can see that the procedure has run. It's created as 2 output tables. So why don't we have a quick look and interpret some of the results? Let's just refresh our tables. Now we can see we've got AP_params, PMML, and rules. So the parameters we import, we don't need to look at that, but let's look at the rules table. So let's open the content, preview. So what we can see is 1 row to represent each rule of the model that's been generated by Apriori. And the pre-rule column first is saying this is like the product the customer bought, for example, product 1. The post rule is if they bought that one, then they also bought the post rule. So if customer bought product 1, they also bought product 2. That's a rule that it's identified from the data. And then we have 3 columns here that basically allow us to understand how good or how useful that rule may be to us. In fact, there are quite a lot of rules that have been generated here. So if we're looking at support, support basically tells us that how often does this rule occur in all the data of all the transactions, or effectively all the baskets that we have available in this data set. How often does it occur that customer buys product 1 and at the same time also buys product 2? So in fact, this number is a percentage. So multiply by 100, it's shown as a decimal. So it's actually 6% of the time. Okay, 006. Sorry, it's 0.6% of the time we are having that rule occur. So it's actually not that often in this data we've got. And we can also see the confidence. Now the confidence basically tells us what number of baskets that have both 1 and 2 in, what the proportion is compared to the baskets that have 1 in anyway. So it's telling us what's the confidence that if people buy 1, they're also going to buy product 2. So that can also be quite useful. But sometimes the support and confidence aren't enough. Because you can have a very high support and high confidence, but maybe the rule is not very useful. So the lift actually provides us the ratio based on the number of baskets that actually have, for example, product 1 and 2, as against the number of baskets that have product 2 anyway. So if the lift is less than 1, it's basically saying the chance of the customer buying product 2 is probably less than if it was just pure random. However, if the lift is much more than 1, then that's trying to tell us that actually this rule is maybe useful. It seems that there's quite a strong relationship between buying product 1 and also the customer buying product 2 at the same time. So when you're analyzing this and using it, you can use this set of rules to build a set of recommendations you might want to make. And for example, if we were to sort by ascending support, we can see the ones with the highest support value, or the ones with the highest confidence value, or the ones, for example, with the highest lift. So with a lift of 3, it means it seems to be a very strong relationship here. Now what we can also see is that the pre-rule and post-rule, it's not limited to a single product. In fact, it looks at combinations as well. The Apriori is able to look at 1, 2 or 3 or more products, both on the left-hand side, the kind of from, and the right-hand side, the to part of the rule. So you can see we've got some good combinations here. So it looks like one of the most useful rules we've got is that when a customer buys product 53, in the same transaction, they also buy products 26 and 37. So there's some interpretation on how you can actually use some of the results. What we may also see here is that we're getting quite a lot of rows returned. It's creating us a large number of rules. So perhaps we might want to filter this and say only give us the rules where the support and confidence is fairly high. So what we can do is go back to the code, and that's where, for example, we might update the parameters, the minimum support and the minimum confidence. Perhaps we set, I think we've seen fairly small values for support, so let's leave that maybe at 0.1, but we can update the value for minimum confidence to 0.2. So if we now update the table and call the procedure again, having cleared out the output, now what we'll be able to see if we refresh our view, we have only a smaller number. It's only giving us the most useful rules that it's found based on the confidence value here. There's nothing that be less than 0.2. And also we could do that on support as well. And finally, one other thing to show you in this first example is that we may want to see the results of that in PMML format. So at the moment, the PMML table that we created is empty. There's nothing in there. However, if we want to see the result in PMML format as well, then we can set the PMML export. So if we run that, and then we again run the procedure, so you would know whether or not you want the PMML before you do this. If we now go to the PMML table, we can see we've got basically that model, that set of rules, instead of being in a physical HANA table, we've got it in PMML format. So if you set the value of the PMML export to 1 or 2, it will output in PMML format to that table. The value of 2 basically is saying use 5,000 characters per row, so it's creating many rows, each with a max of 5,000 characters. Alternatively, if you want to use a club field in your output table, your PMML table, you can have it output into one single row which has absolutely everything in. But beware that this PMML could be potentially quite large if you have a lot of rules, as it's a fairly verbose language. You might have noticed and be wondering what we're going to do with this view we created here. Now, in fact, this view is to simplify the results output that we were already looking at, make it a little easier to analyze, a little easier to visualize. So what we actually do is simply join the pre-rule column, what's on the kind of the from, and the post-rule, the to side, put them together with a little arrow in between. And we round out the support confidence and lift values, just to make it a little easier to visualize. So let's just create that view. Okay, it's now created, and if we go to our views and just refresh this, we'll see now in the views list we've got the Apriori rules view, and if we are now to preview that, we can see we've got a single rule column. So for example, 3 and 6, when people buy product 3 and 6, also maybe well buy product 39 as well. Again, we can sort it based on lift, confidence, and support. But what can be really easy here now is we can actually do some more visual kind of analysis. So for example, we can put the rule on the rows and maybe look at confidence as the value. Okay, so we can see the confidence across rules. But this gets much more interesting if we're to make, for example, a tag cloud. So what we can see here is we've got the confidence giving us the size of the text. And maybe we want to look at the lift as well. We can drag the lift off and maybe color the values by lift. So now we can see the highest lift are the greens. So if it's green and enlarged text, it looks like it could be a very useful rule for us. Now, obviously, we're using product IDs here. In the real world, you may want to use product names, short product names, if you have many of them joined together. So this is one example of how you can easily visualize the output from Apriori as an analyst. So we've seen the Apriori rule, we've understood a little bit how it works. In the next video, we'll see how we can easily make the Apriori simply work on the one-to-one rules. For that, we'll be using the Apriori Lite function.